Hey guys, so in this video, my friend Nam and I are gonna talk about the difference between real engineering in the workplace and school engineering, or like what we thought engineering was gonna be like. So Nam,
Yes.
what do you do?
I am a design and manufacturing engineer at a manufacturing plant in Claremont. They produce, I want to say they're like electromechanical connectors for aerospace and other industrial applications.
And how long have you been doing that?
I've been doing that for 4 years. After I graduated college in 2010, I got a job like maybe 3 months after, and I've been there ever since.
Okay, so we're gonna make this into like a little game, and each of us wrote 5 cards of what we thought engineering was gonna be like and the actual reality. So I'll go first. So I think for number 1 is I thought mechanical engineering was gonna be way more hands-on than it really is. And in actual real life, so everybody has that perception that mechanical engineering is super gonna be like a mix of designing and a mix of like working with your hands too. I think in actuality, none of the engineering positions I had any hands-on part to them. And I would say like most mechanical engineers that I met through school or my classmates, they don't really have hands-on positions either. What about you?
Since I work in a manufacturing plant, I guess I'm a little more involved hands-on than say like a quality engineer or something, who generally have to do a lot of paperwork. But the hands-on things I do are mostly scoping, looking at parts, measuring parts, or well, you know, once in a while, just for fun, I would put parts together, but that's generally just to learn about the products better.
Yeah, it's not like an actual functional role.
No,
it's
no.
just to learn, right?
They're pretty much auxiliary roles. Maybe.
Would you say like hands-on is not as fun as it seemed like it would be?
Yeah, I mean, a lot of the hands-on stuff are repetitive. Putting things together or measuring parts. The way things are designed, they're supposed to make it such that anybody with no education should be able to put together. That's the whole point, because we can't afford mistakes, so we have to make our design like stupid proof, so that almost anybody who's assembling them could put them together.
Yeah. What's your first card?
See, design work involves a lot of creativity.
So what's the reality? Wait, what was the idea that you had in school, and then what's the reality?
Well, you know, in school I thought, okay, well, it's gonna be cool because once I start working, they're gonna give you some general guidelines on what needs to be designed, and you get to start designing from the bottom down. However, that is not the case at all. And there's 2 major reasons. The first one is that keep in mind that you're working for a company. They don't want to spend a lot of money, and if you're going to build everything from the ground up, it's going to cost a lot of money. You know, it's going to be a lot of R&D. You have to order new material and stuff. They generally like to recycle a lot of old designs that have been proven to work, except with slight modifications to accommodate whatever your customers may need. And the second thing is, maybe it's just my specific line of work, but we work off of government documents, and in those documents they already outline exactly what everything should be. You know, how big something should be, how long it should be, what kind of voltage it should withstand, all that stuff. So
yeah.
Basically you're just doing a lot of copy and pasting.
Yeah, that's actually something I noticed too when I worked at SoCal Gas. Specifically, like, closer you are to the government, like, less creativity there is.
Yeah.
Because pretty much our job was to make sure all the pipes were in regulation to each other. And so you don't have creative freedom, you're just following within the laws. Like, the laws take away all the creative freedom that you would get if you had to design.
Right.
So pretty much, I would agree, like, there's pretty much no creative work. I have not had very little creativity in my engineering. The only creative things I've done was Excel programming, where my boss actually didn't know how to do it, so it's like she has to just give me some guidelines and then I make an Excel program, which isn't even mechanical engineering. So yeah, I would agree.
Yeah, you have to keep in mind that when you're making parts for the government, they have to be interchangeable with other parts, meaning the parts that you build at your factory has to be mateable, or individual components, they have to be interchangeable with other companies' parts. So that's why they're so standardized, and that's why they don't want too much creativity, because that keeps parts from
so it's like a USB drive. Like you don't mess with the shape of a USB drive, because then you won't fit with other USB drives.
Yeah.
Yeah. Okay.
That's a perfect example.
So my next card is, I thought being a mechanical engineer was actually going to involve a lot of math in engineering. Out of all the mechanical engineers I know, including you, all of us have agreed that we use barely any math being an engineer. I'm talking, we barely use like algebra, multiplication, and that's pretty much it. Like anything, like even calculus or beyond, never use any of that stuff.
I'm lucky if I get to square a number.
So no math for you too, right?
Just very basic algebra, and what I do a lot, since I work in more of a manufacturing kind of company, I do a lot of tolerance stacking. So it's just basic addition and subtraction.
Do you have you met any mechanical engineers that do a lot of like intense math? Like maybe that's in like what's called finite element analysis. Have you met anyone that works in those fields?
No, not me personally.
I think those positions do exist, but they're like very specific positions. They're very niched, and I would say most mechanical engineering positions are not going to be like that heavy on math.
Yeah, I agree.
Yeah. What's your next card?
My next card. You will need to validate your design with scientific equations. So it's kind of similar to what we were talking about math. You don't really use a lot of the scientific principles that you've learned in college either. Just very basic stuff. You know, all you have to do is understand basic physical concepts. For example, metal expands under heat. Simple stuff like that, but you're never ever required to do a thorough fluid dynamic analysis or a thorough mechanical or thermal evaluation to validate your design. A lot of the designs, basically, like I said, as I mentioned prior, they're basically copy and paste from designs that have been proven to work, and how they validate whether a design work or not is by undergoing testing.
All right. Next card for me. Okay. Next one is making is different from enjoying. And so one of the most common comments I get on my channel is a lot of people that are car enthusiasts. They think, oh, I'm going to be a mechanical engineer. But they don't realize that designing car parts is way different from like riding in a nice car and enjoying it.
Yeah.
I'll make the perfect analogy. I thought of this ahead of time. I listen to music every day, right? Like most people, I listen to music all the time, right? But when I try to make music, I just don't like it. I just don't like it at all. And that's because I just don't enjoy making music. And what a lot of you car enthusiasts are gonna find is that you might really enjoy cars a lot, but as soon as you gotta design something in SolidWorks, it's gonna feel awful for you because you don't enjoy making it. So when you got your aerospace job, did you think it was gonna be like way more engaging than it is?
A little bit. I mean, I knew that for the majority of the job I was gonna just do a lot of paperwork and stuff like that. But it's not like I get to go on the airplanes that I've designed parts for either. So I already knew that was gonna be a little bit, boring. But I've come to terms with it. It's a pretty okay gig, but it's sure as hell not as fun as what I've initially thought.
Yeah. What's your next card?
Okay, so, well, this one was actually something that we already brought up. Hands-on work.
Oh, okay. So we kind of agreed on that. Like.
Oh yeah, definitely.
So like, what do you think?
Let me tell you what my work entails. Generally, well, every morning I do something called material review. Material review. Basically, there's
that sounds terrible already.
Basically, there's a table full of defective parts, and I have to make a disposition on it. Are they use as is, meaning they're fine the way they are? Are they rework? Is it something that we could rework to make them usable, or are they just complete scrap? And myself, and as well as a representative from quality and a representative from production, we look at these parts and we have to all agree on the disposition. Scrap, rework, use as is. Also, most of the days I'm just familiarizing myself with the government specs that we were mentioning earlier. You do a lot of reading, a lot of signing papers, a lot of...
It's a lot of paperwork.
Yeah, a lot of paperwork.
Yeah, in engineering.
Basically, you're just there to to take the fall, I guess. Here, let me elaborate a little bit on this. You see, I thought about this a little bit, and what I think is kind of funny is that for almost every professional job, whether you're an engineer, a lawyer, a doctor, or an accountant,
yeah,
the underlying goal or the underlying role that you're providing to the company is generating legal documents. It just so happens that engineers, their legal documents contain a lot of contains a lot of diagrams and measurements.
Yeah.
But that's what I mean by take the falls. You know, sometimes you have people who aren't very comfortable with moving certain parts along because they think it's defective. So I have to write or sign something that says, yeah, these parts are good. Just move them along.
Mm. Do you know any of your mechanical engineering friends that have a more hands-on position?
Well, tell you the truth, no. Most of them are also office workers. They do similar stuff where they just sign papers.
I actually think yours is actually closer to hands-on than most people, since your office is in the manufacturing plant together.
Yeah.
Most people, I'm not sure if you know this, like people just design things here and they just ship it off to China. That's how most things are made. That's why everything's made in China. And that's why your iPhone is so cheap. So if you wanted your iPhone made here, it'd be like a $2,000 phone, or you could have it, made in China and it'll be a $600 phone. So everybody wins.
Yeah, I mean, I do a little bit more hands-on stuff than my friends because, for example, sometimes when I'm doing this material review board stuff, if I'm looking at a part and if I think I could fix it myself, I just take the initiative to fix it myself.
Mm. So that, yeah, you do have a little bit of repair, but I would say like most mechanical engineers don't do repair at all.
No. And the thing is, it's nobody asked me to do it. It's just something that I do just to kind of mix it up, keep my day interesting.
Yeah, I would say, well, maybe that's another one we can bring up. But my next card is you can't just work for any company. And I wrote this card because I'm bringing it back to cars. One comment I had was like, I live in Australia, I'm really into cars, I want to major in mechanical engineering. Well, I'm going to tell them like there's no way, because Australia doesn't make cars. So if you're, even in America, there's only 2 places, right? Detroit and a little bit of here in California. Besides that, if you're not in one of those 2 places, it's going to be really hard for you to work in the car industry. And same thing with aerospace. Aerospace isn't everywhere. There's a lot in California, there's a lot in Washington, a lot in Texas. But I mean, there's also states where there's no aerospace at all. And to be honest, it's not that great moving. It would be great if you moved to a state that was like fun, like New York. But that's not where engineering firms are. Engineering firms are where there's cheap land so that they can take a lot of it. So I know, like, for example, Lockheed Martin, one of the major aerospace companies, they're out in Oklahoma. It's like nobody wants to relocate to Oklahoma.
Right.
There's another one, I think it's like Lockheed also. They're in Palmdale, California.
Yeah.
It's like nobody wants to move to Palmdale. So relocating for these like defense companies or aerospace companies, typically they move to where the land is cheaper because they need a lot of it.
The price per acre.
Price per acre. But on top of that, when you build in a city, there's more rules in cities. Yeah. And you just can't do a lot of things. So when you do get these aerospace jobs, they're typically going to be in less desirable places.
Right.
Next card.
Okay, my card. You do not need to be proficient in reading and writing. A lot of engineers, they think that they don't take their English classes too seriously. They just. I'm not saying all of them, but a lot. The stereotype is that
it's a waste of time.
If you're good at math, you don't need to be good at. You don't need to be good at writing. But since your work encompasses a lot of reading and writing, especially government documents, you better understand what those government documents are asking of you. Otherwise, you're going to get into a lot of trouble. And as I mentioned before, what you're generating are legal documents. So if you're not very clear about what it is that you're trying to communicate, and you're leaving it up to be ambiguous, it can get you into a lot of trouble.
For me, I actually haven't had that much reading and writing, but I've had a lot of emails back and forth.
Yeah.
So if you want to come off cordial in email, which is like really big thing, and when you work in an office, it's good to be able to write in a way that's fluid, especially when it comes if you're correcting someone.
Yeah.
You never want to come off like douchey, like, hey, fix this, you did this wrong. You know, there's a very elegant way to tell someone that they messed up.
Yeah.
And just one bad email that's like you come off too harsh, then you kind of work. It's really awkward.
Yeah. I'm glad you brought up the email stuff, because as an engineer, you're going to have to communicate with a lot of customers, and a lot of these customers, some of them are like sales reps and people without a lot of technical skills. So you would have to convey to them all the technical information in a way in which they would understand.
This is my next card. My next card. Okay, this is the last card. Okay. I thought engineering was gonna be you're given a really hard problem to solve, and you work collaboratively in a team to solve that problem, because school emphasizes that so much. Like, oh, get in a team for your senior project.
Right.
You were in like a green energy team, right?
Wind energy
team.
Yes.
I was on a team, human powered vehicle team. And then you go to work, and it's nothing like that at all. It's more like your boss tells you what to do, and you do it. There's no like, you get in a group and you talk about like how to solve this problem. And I kind of feel like it's a lie. A little, like, I haven't even had any of my engineering friends that had that experience where they did like collaborate together to solve like an engineering problem in a work life.
Yeah, I mean, basically when you get your design work, yes, the boss does kind of tell you how to go about it, but at least in my case, I get to exercise a little bit more creativity, because since I have more hands-on experience, the boss generally lets me do whatever I want, because they think I'm better qualified to design the parts than they do. But I would absolutely agree.
Do you have anything collaborative at your work similar to your wind project in college?
No, I mean, basically it's broken down to whoever is the expert in this specific product or that specific product. Every time a customer asks for something, it just goes directly to that person, and that person is generally 100% responsible for putting everything together.
Yeah. What's your last card?
Last card, you don't have to be personable. Meaning, when I was in college, I thought engineering work was going to be like, all right, well, I'm just going to be locked in a room by myself and just working with machines and tools and stuff, and nobody's going to bother me, and I don't have to talk to anybody. But that is definitely not the case. You are going to have to talk to a lot of people, and especially customers, and the way you come off to them is very important. So you have to have a good personality, and you have to be able to communicate well. So for you engineers who don't think that soft skills are important, they are very important.
Yeah, that goes into a lot with cultural fit. It's really hard. Even if you have really good social skills, if you're not a cultural fit, everything is just socially awkward.
Yeah.
And that's the hardest part about being an engineer. If you're like a really social person, say if you're, I think this is actually, there's a article saying a lot of girls who are, so there's already a few amount of girls going into engineering, but the ones that are going into engineering and getting jobs, a lot of them are leaving to do other things like becoming a teacher. And I really think a lot of that is because they just don't like the environment. And I just think it's not like, if you're a social butterfly, I think it's a really bad place to work in most cases.
Yeah.
For me, it's like getting along with other engineers. That's probably one of the hardest parts of my job.
Yeah.
Because, yeah, engineers are pretty arrogant.
They are.
And it was probably like I would never want to hang out with those guys for a minute outside of work. It was that kind of deal. In most cases of most jobs that I had.
Yeah, I mean, most of the people who I hang out with at my workplace are the production people, because you know they're just like your regular everyday people.
Yeah. I get some comments on my channel saying I'm a jerk. Man, you should meet some of these engineers.
Oh, yeah.
They're way more
worse.
douchey, like way more douchey. And it's funny because like a lot of people want to be engineers. I'm like, dude, you're gonna face douchey guys for sure if you work as an engineer. There was not a single company where I worked for where there was not like an arrogant engineer.
Yeah, but don't be a douche.
Don't be a douche.
Yeah.
Thanks for checking out that video, guys. If you guys want to check out my last video on mechanical engineering, you can click over there. And if you haven't subscribed yet, go ahead and subscribe because it'd be awesome to have you as a subscriber. And thank you for watching. Bye. In mechanical engineers is to get really good at SolidWorks on your own way. Just find a way to get good at it. Practice, do the tutorials, maybe enter a student competition and do all the SolidWorks works. And then that is going to help you a lot when you interview because a lot of